Now, let's start second question today. So you have 45 minutes. You can do this question, and the first you need to explain to me the idea first, and then you can code it up, and finally, hopefully, you can tell me the time complexity and the space complexity. Can you start the timer? Yeah. Okay.
Okay.
Start it.
Okay, cool. Today we're going to solve LeetCode number 15 called threesum. So given an integer array nums, we want to return all the triplets, meaning 3 different numbers from our input, such that the numbers are all unique and they all sum up to 0 when you add them together. So you notice that you cannot have duplicate triplets in the solution set. So what this means is just because you have 101 doesn't mean you can have the same thing in a different order. This is considered a duplicate triplet because the frequency of the number is what we're going by when we say duplicates. So this is invalid. And so this question really requires us to understand how the 3-pointer pattern works. So what we're going to do first is sort the input array so that we can do this in a way that maximizes the time complexity. So if we sort the input array, so this is the original input. What we get is -1, -1, 0, 1, 2, 4. Cool. So now what we're going to do is use a 3-pointer pattern. And the reason we do this is because the array is already in sorted order. So let's call this first, second, and third. What we're going to do is we're going to add all the values together. So -1 plus -1 plus 4 is equal to 2. Is 2 equal to 0? Nope. So 2 is too big. And this is the key point. Because 2 is bigger than 0, what we're going to do is we're going to move the pointer down from the right, from the end. Because again, we already know this is in sorted order. So now we're going to have pointer 1, pointer 2, pointer 3 move down in the last position. We're going to do the same thing. So -1 plus -1 plus 2 is equal to 0. So cool, we found one pair of triplets. So we have a resulting list. Let's just append to it. So it becomes, let's append -1, -1, 2 to the resulting list. And notice how we can't have duplicate triplets, and we're going by frequency. So that means that we need to increment, or we need to move both pointers towards the center so that we never have a chance of using them again. So now first is here, second is here, and third is here. We do the same thing again. So -1 plus 0 plus 1 is equal to 0. Cool. Had we not moved this pointer down, then we would have had a chance of a repeat triplet, just because of the way statistics work, because we want to minimize the chances of having triplets that have duplicates. And because we move this pointer all the way towards the end, eventually we're going to catch all the triplets that we may have missed when we're doing this. So we have another triplet in our result list that we're going to append. So now our result looks like this. 1, 0, 1. And cool. So because we're at 0, we can move either pointer towards the middle. Let's say we want to move the small pointer forward. So small is here, right is here. Now this is a condition where, first of all, we're on the same pointer and we can't have that happen. So what we're going to do now is we're going to reset our pointers when the second pointer crosses the third pointer. Now, at a first, Second is always one digit in front of the first pointer. And right is always at the end. So the first pointer moves. And we're going to do this until we don't have room anymore for 3 pointers, aka we go out of bounds. So again, -1 plus 0 plus 4 is equal to -3. Oops, is equal to 3. 3 is too big, so we're going to move the right pointer down. Fast, slow. Pointer down from here. 1 plus 0 plus 2 is equal to -1. Okay, now we're too small. Or this is 1. We're still too big by 1. 1 is bigger than 0. We're too big. We always move the right pointer down. At least until we cross between second and third pointer. So second is here. Right is here.
And now you find it. You find a triplet.
1 plus 1 is equal to 0.
Mm-hmm.
So we found a valid triplet. And we're going to append to the output list. Notice that this triplet is not in here. Because we decremented both pointers towards the middle. We didn't just decrement one pointer when we found a result. We decremented both pointers. So result is equal to -1, -1, 2. 1, 0, 1.
Okay.
And -0, 1. And so now when we move both pointers, you know, they're beyond crossing.
Okay, beyond crossing.
So first is here. Because we found a result, we have to move both pointers down. So right is now here, aka third pointer. Second is now here. Second is not less than third. So we have to reset our pointers. The first is now here. Again, second is always 1 ahead of the first pointer. And the third is at the end. Again, 0 plus 1 plus 4 is 5. 5 is bigger than 0. So same thing. I'm just going to copy this again. First, second, third. 3 is bigger than 0. So is bigger than 0. So first, second, third. They're crossing, so we have to reset. And notice as we get towards the end, the number of iterations gets smaller because we're not looking for duplicates and we basically use process of elimination here. First, second is 1 ahead, and third only has 1 place. So we basically know we found the results. So I'm not sure why this is 101. This shouldn't have been here. Let's see.
101.
1 plus 0 plus 1 is not equal to 0. -1, 0, 1 is 0.
So doing this quite before, did you sort it? You already sorted, right?
Yes, I sorted it.
Okay.
Let's take care of that later, but 1 plus 2 plus 4 equals 7. 7 is bigger than 0. Done deal, same thing. First, second, third. Okay, now we're running out of room because these have crossed. We're gonna try to push first forward to 2, but we can't place the pointers. So we're out of bounds, so that means we can return the resulting array. But I must have made a mathematical mistake here because this is not, it's a 0. Okay, there was a mistake. I didn't include the -1. And, okay. -1. So as you can see, we basically found the result here.
Yeah.
All of this is just repeated duplicate work or way too big and we ran out of room. So that's the idea behind this solution
So
at a high level.
yeah, your idea is just create a 3 point to find the
Yep. And it
result,
works
right?
because we're sorting the array. If we didn't sort the array, this wouldn't work because we can't subtract right. We can't add left just because we're too small or too big until we get the perfect zero we're looking for.
Okay.
So now to code this up, first of all, we sort the input array. We want to create our 3 pointers.
Okay.
So we're using minus 3 because minus 2 because we have 2 other pointers that we need to place. So this is super important, this step right here. I think I forgot to mention it in the picture, but we need to check that we're not placing first on the same pointer again. So because in our input, remember we had -1, -1. We want to make sure first is not the same as the previous one. If it is, then we're going to keep going. So first is bigger than 0 and nums of first equals nums of first minus 1, then we can continue. We're not going to place the second and third pointers yet.
Make it sense here.
Why we're doing first is bigger than 0? Because if we didn't do first is bigger than 0, we would go out of bounds to the left of the array.
Okay.
If this is not true, okay, we found a different element. Let's say 0. Cool. Then we can place second in front of first, and we always place third at the very end of the array. And then remember, we cannot cross our 2 pointers because we can't have duplicates. So if they overstep each other, first of all, that's a duplicate, because if second and third are both on 2, that's not valid. And if they overcross, we've already found that number in a previous iteration. So that means we're wasting time. So while second is less than third, 3 sum equals nums of first plus nums of second plus nums of third.
Okay.
If 3 sum is less than 0, then we need to get bigger. How do we get bigger? Well, we move our second pointer forward. If that's not the case, if our 3 sum is too big, then we're moving the right pointer down. Else, if all 3 elements add up to 0 perfectly, then we're going to append nums of first, nums of second, and nums of third, right?
Yeah, you can attribute it.
And we don't want duplicates, so we have to move both pointers. After we move both pointers, what are we going to do? We're going to make sure that, and I don't think I drew this point out, but the pointers we're coming from, just like with the first pointer, cannot be the same because, again, we're not looking for duplicates. So if if this was -4 and we came inwards with right pointer, this is also -4, we would keep going because with the same rule here, we don't want duplicates.
Okay.
So while second is less than third, remember, we cannot ever cross because we don't want duplicates. We don't want to waste time by rechecking the same elements we've already checked. And nums of third, nums of second equals nums of second minus 1, because second is coming from the left inwards. Then we're going to keep incrementing this, and we're going to keep doing that as long as we keep finding duplicates. We're going to do that forever as long as they're not violating this condition. While second is less than third, and we do the same with our third pointer. Nums of third plus 1. Why are we doing plus 1? Well, third is right pointer is coming inwards down from outside. So third minus 1. And so now we've made sure that we don't have duplicates. So the only thing left to do, Python is very strict with indentation, is we have to return our resulting array, which I didn't even define until now. So this should work. Let's run this.
Okay.
As you can see, there you go.
Okay, let's talk about the time complexity and the space complexity.
So the time complexity of this is actually O of n instead of O of n squared or O of n cubed, because using this two pointers technique, we really only have to loop through the array once. We're still on the magnitude of O of n though, because even though we have to do all these operations, technically first pointer is doing it in the most efficient way as possible, because we're eliminating things based on what we know. So the space complexity, I believe, is O of 1. We're not using any extra memory. We're just storing things in a resulting array and appending to the array and using the pointers to do all the work.
Okay, good. I think your explanation is really impressed for me. So thank you for doing this question. I will start recording.